Hello and welcome. I'm Andreas. I work as a trainer and consultant primarily for C++. And I'm also the creator of C++ Insights. And this is also the tool I like to talk about in this series. In this episode, I will explain what C++ Insights is and give you a little introduction in where you can find it and how you can easily use it. So in today's episode, I like to talk about a C++ 17 feature, and this is if or switch with initialization. We have a little more code to make the example work today, so all the lines from 1 to 7 are just to make the example work, and the topic of today you find in line numbers 11 to 16 here. So here in line number 11 and 12, we see such an if with initialization. That means that I can now have a variable declared before the actual condition of the if statement, okay? We know this from, for example, for loops for a long time. So in a for loop, some typical pattern is writing something like this. Here, this is our initialization. Here we have the condition, and of course there we have the post operation, which usually is an increment. And for if statements, we simply can say we don't have the last one here, so we now can have the first two. We can declare a variable and then the condition is checked. And this is exactly what I wrote down here. And there's a reason why this comes in handy. My if statement here that declares a lock guard called lock, acquires a mutex, and after that it checks for a condition. So in my case, this function changeScreen is supposed to be called once we have a new screen in our system or the default screen got changed. So we call this function, and this particular assignment that has to be guarded so that two threads don't tamper with the screens at the same time. So statement in line number 12 and 15 that must go in a locked scope. So we first compare in line number 12 whether our screen is the new screen, so we practically don't have a change screen, so we can return, and otherwise that's the else in line number 15. If we have a different screen, then we assign it to this global screen variable, and then we send around a update notification. And the latter one, that's no longer subject to our locked scope. The if with initialization here helps me to declare this lock guard in the narrowmost scope in the if where I need it. You probably also know a lock guard from C++ 17. That means once we go out of the scope, then this lock guard releases the mutex. This is handy, and if we look at the transformation, we can see that this is nothing really challenging or something that we couldn't do ourselves. So the compiler first opens a new scope for us, and then it pulls out the variable we declared in this if statement just before the if. It declares it like we did, and then we are looking at a plain regular if as we could write it since C++ 98 or even earlier, since the C days, okay? So this is one of these features where the compiler only adds a little bit of syntactic sugar, removing the need from ourselves to introduce this new scope and have a new indent and so forth. So that's really great. However, with this if with initialization, there are coming some, potential new error sources. Say I would do something like this. And so I have an else if, I create a new variable there, call it log, assign a value 4 to it, then I'm simply doing a silly check here, is log is not equal to 1, then go in that branch. So that's obviously nonsense code, but I like to show you here the thing you have to watch out for. So each time we have a if with an initialization statement, the compiler does this syntactic sugar, creating a new scope, moving the variable out and then having the if. So this was true for our lock guard. And this is also true for the else if, because in C++ we don't have an else if, we only have a if and the else. And what we read as else if is the combination of a else case which has a if inside. So that means that we have here another scope, and the compiler moves out the variable lock, and we have the check here. And what you now have is variable shadowing, because we have two variables in the scope here which are called lock. And this is legal, sadly, in C and C++. As I said, it's called variable shadowing. It means that the most narrow variable is used. So in my case, the code would work as expected. We ignore the fact that it's really silly at this point, but it would do the correct thing, but the other variable is still around and reachable, which is good if, say, we want to say something like lock.release at this point to release the mutex earlier, or the lock guard. We can do this because it's in the scope of the else. But what you have really to watch out for is this variable shadowings at this point. And another thing, especially with this lock guard, is some people say, well, I acquire this lock at this point, so we don't use it, so why bother giving it a name? So we simply delete that one, right? And if I do the transformation, and we can see, of course, we end up with something like this. But look at what this is. This is the declaration of an object of lock guard initialized by gmutex. It's not a variable. It's the creation of an object which is immediately destroyed after line number 17. There is no lock going on in my if or my else. So remember to always give your variables names in this case, even if you use a underscore. Just to say, I'm not caring about the name at this point. I just want that lock to be in place, okay? Now we have back a variable. That's important at this point. As I said, we see the similarities to a for loop. This is not what I'm advocating for, but you can also use comma operations here to say something like I, X, or epsilon, declaring multiple variables in a single line. The rules are the same as always in C++. They now must all be of the same type. So we can only add pointers, but the base type of the variable is the same. And then we can see, of course, they are all created outside if, but in the scope. That means they are no longer reachable after we ended our else branch. This is not a typical pattern. I think that's something that you should use, but you can. For me, it's mostly what I started with, something like this, where I want to acquire a lock or have something that only should be used inside the scope of this if or all its else branches. I hope you learned something from this and can refactor your code, maybe dropping a few lines of repetitions or narrowing down your scope of your variables. That's it for today. Stay tuned for the next episode. Bye bye.